everyone, and welcome to Ditch Diggers Dialogue Volume 17. Thank you for joining us this morning. For those who don't know me, my name is Ashley Hudson. I'm the Operations Manager with the Heavy Construction Contractors Association. If this is your first time tuning into a Ditch Diggers Dialogue, welcome. HCCA strives to provide educational and networking opportunities for our membership, so we created the Ditch Diggers Dialogue series as a virtual way to stay connected. Today's session will be hosted by John Irby and Kateri Simon of Luck Ecosystems. Both John and Kateri have been with Luck Eco since 2016. John's depth of experience spans environmental construction, turf establishment, botanical research, landscape design, and nursery management, while Kateri brings years of civil engineering and construction management with a passion for sustainability. Through today's session, they hope you will learn the best practices for bioretention installation. John and Kateri welcome you all to ask questions throughout today's session through the use of the chat box or by raising your hand and unmuting. With that, I will turn it over to John and Kateri. Thank you both for being here today, and the floor is yours.
Thank you so much, and thank you everyone for joining us for this hour. We hope that you find the information we're going to share helpful. I'm going to be just leading off the presentation with an introduction, and then John will be taking over from there with some of the details. As Ashley said, please feel free to ask questions throughout in the chat box. We will try to field them as we go along if we feel like it's a pertinent question to have answered as we go through. So I wanted to go over the contents of what we're going to be sharing today. John, if you can go advance the slide. We'll be starting with an introduction of Luck Ecosystems. Just want to make sure everybody understands what our company does and how we operate. I'll give a brief introduction as well to bioretention. I'll go over a brief word of caution and try to highlight what we really try to accomplish from this presentation. And then the real depth of the content will come from the steps of construction for bioretention, going over common pitfalls, and then we'll just have some time to recap and definitely answer all your questions before the hour is through. So this brief word of caution is important to say, so I'm just going to read it here. So while we hope the information provided in this presentation proves helpful, it's not intended to supersede the engineer's plans. Rather, our intent is to increase the general understanding of biofilter basics while raising awareness to common pitfalls, thereby encouraging increased discussion between the contractors in the field and the engineers so more successful installations occur. And while this is definitely a good word of caution, it also highlights what I really hope that we can accomplish from this presentation today, which is increasing that discussion between the contractors in the field and the engineers. So I have background in civil engineering, and I know that a lot of the aspects of design of bioretention come from engineers and designers with various levels of experience with bioretention. So we feel like the more engaged and the more knowledgeable that contractors in the field can be about bioretention, they can help ask the right questions, and everybody can be on the same page to avoid just any basic practices that could be implemented to prevent catastrophes from happening in the field or any problems. So I think everybody is in agreement that if we can address any concerns on the front end of construction, you wind up saving the project a lot of hassle in the end if something does wind up going wrong. And then a little bit about our company. So Luck Ecosystems is a division or a sister company of Luck Stone. So Luck Stone is a family-owned aggregate business that's been around for almost 100 years. So we're about to celebrate our 100th anniversary, and we're family-owned and a values-based leadership company. I know John and I both really love working here. And then, so Luck Ecosystems is a sister company to Luck Stone that has an environmental focus, and we really provide a wide range of products to enhance the outdoor experience, from biofilter to topsoil to ball field and athletic field root zones. And we specialize in blended sand, soils, and compost for that related work. And we utilize a lot of the quarry byproducts to make the work that we do effective and both have a positive environmental impact. And we also wanted to give an overview of bioretention, realizing that there's probably various experiences with bioretention here in the audience. So just a really quick overview, bioretention is really meant to treat stormwater runoff from impervious surfaces. And it does that by capturing contaminants and sediments that run into the basin. And there's other components that are important for the function of it, like the grass buffer strips, gravel diaphragms, forebays. Those are all intended to do pre-treatment so that the larger materials are collected and easier to maintain. Captured in the bioretention, taking up those contaminants and nutrients into the biomass. So when we talk about the contaminants, mostly the things that are targeted in these systems to meet the stormwater regulation requirements are nitrogen, phosphorus, and sediment. So when we talk about contaminants, that's mostly what we're talking about. And bioretention can take a lot of different forms. One of them is, like, for example, a grass swale. So it can be very linear or it can be very large and pond-like. And the next slide shows a good example of what a bioretention system might look like, just as a diagram of one. You can see that runoff is coming into the pond from an impervious parking lot in this example. And there is the flow path that the treated stormwater runs out is through an underdrain in a gravel layer at the bottom of the pond. And you can see the filter layers that are installed in the bottom of the ponds as well. What's missing on this diagram is it doesn't show an overflow structure. Typically, all bioretention would also have that overflow structure, so that once the initial rainfall, which is the dirtiest and most contaminated amount of water, flows into the pond, that water is treated, but then any excess can flow out of the top of the system. So from here, I think John's going to get into the details of the construction steps.
Thanks, Kateri. Some of those biofilter basics. I'm going to start covering the steps of construction. The steps of construction, I'll just give a brief overview, almost like a table of contents again of what we're about to cover. It's going to include a pre-install meeting. There's going to be an excavation step. You're going to then install a stone layer. You'll build an underdrain. Next, you'll install a choker layer, and then you'll have a soil media placement step. There will be some pond protection measures that you need to take. And then lastly, there will be a final inspection. So let's get into each step and we'll kind of break them down one by one. All right, so the pre-construction meeting. In this presentation, I've broken things down to kind of divided into the main point and common pitfalls, and just kind of divided things into these categories. So each step will go through that same, and you'll kind of get the swing of things as we're going. So the pre-construction meeting, what's the main point? This is a great time to discover any discrepancies from the plans to what you're finding in the field. For example, you may find additional drainage area that flows toward the basin outside of what is shown on the plans, which could make for your basin being undersized. I've certainly seen this before where, the outside perimeter of the plans go to the property line, but there are roads and other parking lots that are far outside of that area that drain toward this toward this property and ultimately make their way toward the basin. And we've seen basins be extremely undersized when that was not thought about. This is also a great opportunity to get a sign-off schedule, and make sure all parties are in agreement and it's understood who is to care for this basin after your installation is complete. Some of these points I'll make multiple times throughout the presentation today, but all too often we see either a site contractor or a subcontractor install a basin, and then a lot of additional steps to that site's development and the construction project have to go on, and you turn your back and you leave. But the GC and the additional subs that are on that project aren't aware of their responsibility of taking care of that basin, and eventually bad things can happen, like sediment contamination and things like that. What are the critical touch points? What are the points of the pre-construction meeting that you're going to really want to make sure you're hitting? Do you have the latest set of plans? You know, that's critical. You're going to want to make sure you're building to the latest set of plans. Permits and submittals. You only want to install approved media, so you want to make sure you're using approved media, approved stone. Just have those things all approved and ready to roll, so that you don't have to pull this media out or answer a lot of questions for installing stuff that wasn't approved. Again, some of you on the call today, some of this will be no-brainer stuff, but I want to make sure I'm covering stuff for people that have really never installed one of these before ever. So some of this will be pretty rudimentary, but we'll get into some more detail too. You want to make sure you've assessed the site access. You know, how are you going to get that media over to the pond? You know, are you completely landlocked and behind buildings? Are you going to be able to get dump trucks back there? Or, you know, ideally, could you dump some of the media directly over the side of the pond into it? You know, are you going to have to get really creative and use stone shooters or telebelts or what? You know, just some of that needs to be thought about. And then lastly, utilities marked. You know, you want to make sure you've got those utilities marked before you get in there and start digging. And then the next section is potential pitfalls. You know, where could this go wrong? You know, lack of a stabilization plan. That is, again, going to be a common theme here. Ideally, in a perfect world, we would install these basins after everything was perfect and the grass was all grown in. But as many of you know, that can't be done. Sometimes these systems need to be installed behind buildings. And it just makes sense to get them in first and then get the buildings in later, or something like that. Or it's at the wrong time of the year before stabilization can occur. And so you just either want to have a plan for stabilization or a plan for protection. Again, kind of along those same lines is what the site water. You know, all of these systems most of the time have the site water designed to flow toward the basin. All the parking lots flow in that direction, and all the contributing drainage area flow in that direction. And so, you know, that's great after the basin is installed, but what do you do while you're trying to get it installed or get that gravel in? And so you need to think about silt fence and berms and other water diversion techniques that are going to keep your site dry while you're getting this thing installed. And again, not understanding that contributing drainage area. You got a lot of water volume coming at you, and you just want to be prepared for it. All right, next step. You're going to get into the excavation step. You know, what's the main point of this? The correct size, the correct shape, and the location. You know, some of this seems a little silly, but, you know, and I'll cover it again, but digging this thing incorrectly, for one, you could be called out on it, but two, the material that comes out of the hole is often fill dirt, and what goes in the hole is purchased material. So getting that thing the right size and not too big is a cost of savings measure. What are the critical touch points? You know, you're going to want to make sure everything is surveyed and that you've got the cut sheets supplied. Does the hole match the bid amount? Again, back to that correct dimensions and the correct elevations. What's your plan for waste soil? You got a lot of soil coming out of this site. Where's it going to go? Now we'll get into some common pitfalls. See it all the time. You get a little aggressive with the digging. That's expensive. If the basin has been used as a sediment trap, you know, a lot of times because everything flows in that direction, it's a great opportunity to kind of allow it to be a sediment trap during that part of its life, and then later convert it over to a functioning bioretention basin. And if that's the case, you know, you need to check to make sure is that elevation at the bottom still correct, and if not, you may need to dig it out a little bit. And then, is there groundwater seeping in? This is something to be watching for. If groundwater is seeping in, this site is likely not suitable for bioretention, and that's something you want to immediately draw attention to the specifying engineers and the inspectors and things like that to make sure that you just don't carry forward and install, or else you'll have a failing system and a little tough to prove and determine what's going on with it later. It turns into an investigation instead of just calling these problems out from the get-go. And then a real quick, a helpful tip, a really great idea is to have your surveyors provide 5-foot offsets around the outside of that basin when they lay out the dimensions of it for you. And that way your excavator operator can cut away his line, and then anytime he gets a little bit, needs to just check his dimensions, he can measure in from those 5-foot offsets and can always check to make sure he's cutting that basin's profile and dimensions perfectly. All right, the next step we're going to get into is installing the stone layer. What's the main point of the stone layer? So maybe not the main point, but a concept that people need to understand is that stone layer in the bottom. When that system gets inundated with a lot of water, especially in the case of a system that does not have an underdrain, where it's intended for all that water to percolate into the soil below, that stone layer is to provide a water storage area. And that kind of helps you understand why it's got to be so clean and things like that. Again, the correct size stone, and from a approved source, you want to use clean stone. You want to use the correct size stone, and all of that has to do with void space. So there's a lot of calculations that have been gone into this thing up to this point. And so the size of the stone and the volume of that stone and the depth and all of that make a difference in how much water can be stored in that void space, in the air space of that stone. Again, you want to make sure this stone is clean because this is a drainage and storage area. Critical touch points. You want to make sure that this meets the plans. You're going to have the correct depth, the correct material. The bottom of the profile of the pond is per spec. We've seen over time the profiles of ponds change a little bit, and this is kind of along the lines of the excavation step as well. But for a long time, they had sloped sides, much like you might see a natural pond. And then through time, we've started to see a lot more straight sides. And I think it makes some of that maybe because of the ease of construction and the ease of volume calculations. But you want to make sure that those side profiles and shapes are correct. And do you have a plan for installing this material? And I know that sounds silly, but are you taking steps to think about how you're going to get that stone in there without getting out on top of it? In many cases, you can in the stone layer, but especially critical with systems that don't have an underdrain. You want to make sure you're staying off of that basin at every step of the process to avoid compacting that soil below. And it's also just good practice to get good at installing these things without getting out on them. It's a good thing to get clever about. Next on this list of critical touch points is fabric or not. Over time, we've seen things change to where fabric is kind of fallen out of favor with designers because it does create a potential additional clog layer. But if your specifying engineer has specified fabric, you just want to make sure you're using the correct fabric, woven or new fabric. It's not an opportunity to use fabric from something else and try to skimp there. The common potential pitfalls that you may face in installing the stone layer: using incorrect stone, using dirty stone. As you can see, these are kind of the opposite of the critical touch points. And then you could start with clean stone and then contaminate that stone from improper handling on site. That could be delivering that stone with a dirty truck, not washing the truck bed out. And you could also do it, but just dumping it on the site and not doing a good job of getting it in the hole clean. All right, moving forward. Now we're going to build the underdrain and install the choker layer. What's the main point of this? The underdrain allows excess water to escape the pond that does not percolate. That's a good thing to understand. And the choker layer serves to separate the media from the larger void-sized stone. This is a bridging layer. This is to what keeps the media from washing down through. I've seen ponds installed with the drainage layer being number 3s or 57s, certainly plenty of times. And so, this media may or may not bridge on that, but you often use a choker layer to create a bridging effect. All right, the critical touch points. Does the pipe match the plans? You want the correct hole diameter, the correct spacing, the correct layout, and all of those things. And a quick little story, which you may not see in Northern Virginia or in Virginia, but in DC, there are certain projects where everything on the project has to be made in America, for example. And this was just, we were talking about this internally, and someone shared a story like this, that they had seen this happen, talking about correct pipe. And the pipe was made in China, and the inspectors came and made them pull it all out. And so they had to find pipe, I think, made in North Carolina or something like that. So while that might not happen, and that's an outlier, that probably won't happen all the time. It just gives you an example of needing to read that fine print. Number of cleanouts and observation wells. This is something that's easily countable by a inspector. And so he's going to be able to really walk out there and count them up quick. And so you want to make sure you don't miss one, and you want to make sure you get them all in the right spots. Again, proper fabric and placement if required. And potential pitfalls. Similar to the drainage layer, this must be clean. You can see these guys, they're installing the drainage layer, and then now they're starting to put in the underdrains. And the reason I mention that is you have to remember that the underdrain typically is within the drainage layer, not the choker layer. So it's down inside that drainage layer and basically shielded from the media, and then the choker layer goes on top of that. And so the media never touches the underdrain pipe. It never has an opportunity to really wash down in there. All right, here's another quick picture showing a choker layer being installed over top of a drainage layer. As you can see, the drainage layer is down inside what I assume is 57s, and you've got some observation wells and some clean outs that they're laying out there and getting ready to turn them up and put some standpipes up. And then on top of that, they're putting pea gravel as the drainage layer. Now, in this case, they've got an excavator out on the pond, which is not the best practice, but again, this pond has drainage, under drains, so it should be all right. This is also an example of a basin being built with slope sides. All right, so moving on to soil media placement. This is a big one. What's the main point? This is one of the most important steps of the process because this is so easy to mess this up. And this is a lot of times where people that are they're so used to doing traditional site contracting and things like that, that it's easy. They get it under their belt quickly, but their first time or two, it's a wake up call at how sensitive some of this stuff is. It's not hard. It just needs to be kept clean. So what are those critical touch points? You want to use high quality media. it needs to be tested and approved. You want to work with a vendor that's doing a lot of QC testing and delivering media that the test data matches the media, and it's not, year-old data or 6-month-old data, and where that media being delivered to the site is completely different than what was on paper. You just want to really make sure you're using good stuff. It is not an inexpensive process to install bioretention basins, and so the last thing you want to do is have to tear one out and do it again. You want to make sure you're using clean trucks hauling. While a single clod of clay is not a big deal, if it were abundant and recurring, it could cause an issue. But most importantly, when you have your media coming to the site and all of a sudden it gets dumped and a few big clods of clay dump out, that just doesn't sit well with inspectors. It just doesn't look like people have got their ducks in a row and that they're watching this thing closely. And so if that happens, that's just a conversation that you want to avoid. You want to make sure you have a clean area to dump in, and you want to avoid site contamination. As you can see here in this picture, these guys are dumping right into the pond, and they've made themselves a ramp. This is obviously going to be a really big basin, so they're trying everything in their power to get that media in there in high volume and quickly. And so, but they've actually laid another piece of plastic down up that ramp just to give them another opportunity to kind of clean the tires off and make sure they're not tracking mud and debris into that pond. And then, yes, again, do you have plans in place to avoid compaction? And later on in the presentation, I'll cover a lot of the ways that this media can be installed and avoid compaction. But you want to have that in your head, and driving out there with a bulldozer, it should not be one of the plans that you plan to use. Potential pitfalls. Not watching the weather. This is a big one. You get the stone layer installed, and you kind of almost need to be timing these things and trying to get them all zipped up and done within a window of dry weather. And the last thing you want to do is maybe get the stone layer installed and you haven't thought about why would you need silt fence up yet. Maybe you haven't thought that was a needed component because you're not onto the media yet. And then you have the rain come in and wash mud on top of the stone layer, which again needs to be clean, or on top of the media. So you want to be watching that. Site contamination from trucks tracking it in there, equipment tracking it in there, runoff, things like that. Compaction, driving out on it. And erosion control measures in place. Again, we'll hammer a bunch of these points over and over, but everything is designed to flow toward these basins. And so you've got to have plans in place to protect them before, during, and after construction. All right. And then lastly, installing while wet. That's a good point. This stuff will be moist when it's delivered, but it doesn't need to be sloppy wet. It doesn't install well when that happens. It kind of slops into the basin, and that causes it to a lot of the airspace and the fluffiness to fall out of it. And you're just starting at a greater level of compaction than you'd like. We want to take every step possible that we can to get the stuff in there nice and fluffy and reasonably dry. All right, here is an additional photo just showing to kind of illuminate your ideas. As you can see, this is not a paved surface. They're not on plastic, but they have taken the care to find a hard packed area on the site where it can be scooped up with minimal contamination. So long as they just don't dig way down deep into that base layer below. And then moving forward, we're going to talk about the various recommended media placement methods. All right, so we're going to kind of break them down one by one. Skid steer and excavators, we're going to combine into one step and show you some options. The skid steer and excavators are the most commonly used install methods in most jurisdictions. As you can see in this picture, they're using a long stick, long reach excavator, and that's doing a really great job. They're able to get every bit of this material into this basin without ever getting out on it at all. They were able to do so with the stone, all of it. And so it just kind of shows you that where there's a will, there's a way. And you can get this material out there in these basins without driving out on them. Some areas have gone so far as to disallow placement techniques that require getting out on top of the media. Spoke to some contractors working in Northern Virginia, and they were from Pennsylvania, and that's what they shared with me was up there in their area, they could not even drive out on them for any reason at all. Skid steers and excavators can be successfully used. You know, just again, it just has to come down to a few things being respected. It's best not to get on top of the media. Long stick excavator where needed. And here's a good one. If you're going to use a skid steer, and that's fine, not everybody has to own every piece of equipment in the world, but if you're going to use a skid steer, you can install it in what I like to call the wave. And that's when you start in one end of the basin and you work your way across. You know, unlike, let's say, sports fields or things like that, where they'll install media or topsoils in layers because they want even compaction, and they'll put them in what's called lifts and compact that to a given level, and then another lift and another lift. You do not want to do that in bioretention media. You want to install it in the wave. And if you're going to get out on the media, you want to use lightweight skid steers and mini excavators with wide rubber tracks. And you want to fluff your way out and kind of dig where your tracks were to decompact where you just drove, if at all possible. So that gives you some ideas on, if you must, you can still fluff that media back up. All right, moving on, show you some more options. Here's a video. I hope that's playing for you guys. This is showing a stone shooter installing the media. As you can see, it does a really nice job. Very low labor, zero concern with compaction. Does a really nice job of putting an even layer. I mean, these guys don't even have much to level up and rake at the end. And so this is a really great option for install if you have access to this equipment or if you can rent it. In this video, this contractor is installing this media using a telebelt. Now this is quite the reach. Stone shooter probably wouldn't even, I guess it would probably get it there. One thing about it, when you're stone shooting from a really long distance, the compost particles in media are lighter weight than the sand particles. And so if you're really trying to launch that media with a stone shooter really far, you can get some segregation of the media because the sand flies further and the compost flutters out. And so in that case, it's better to switch over and use a telebelt where you can just conveyor that media over there and lay it down. I mean, as you can see here, they were able to get a large volume of media over a very long distance in a really tight spot. All right, now we're going to get into pond protection. You know, as you can see, a picture is worth 1,000 words. And in this case, potentially many thousands of dollars. Even with super silt fence, as you can see on the picture to the left, or actually in both pictures, even with super silt fence up on the uphill side, and they had, you know, erosion control fiber mats down, they still had a blowout occur. Now, luckily, this basin was covered with filter fabric, and it didn't suffer any damage whatsoever. You know, this shows a great, inexpensive way to protect any basin during construction. You know, you can lay this out over your steps. If you have to leave for the weekend, you can. But getting it out there and getting it nice and tight and buttoned up, especially when you're done before the landscapers move in, if that's being subcontracted by someone else, that's a great way to get your basin signed off on and say, hey, you know, we installed it correctly. It's nice and clean. And then your work is protected underneath. Again, we all know that Sometimes these just have to be installed before complete site stabilization can occur, whether that's the weather or just the construction sequence. And then lastly, we'll talk about final inspections. You've got a basin installed, you're going to want to do, oftentimes some jurisdictions require a flood test. That's a good thing. That's a great way to demonstrate that you installed a successfully functioning basin and to get signed off on. We've talked about several times through the presentation that, you want to make sure you've kind of got it in your head. And it was talked about in that pre-construction meeting about, when does my responsibility get released? When is my job here done? I have seen it many, many times where a guy or gal, a construction company will install a basin and do a really nice job. And then all of a sudden things get delayed and the landscaper is supposed to come in, or maybe they even cover it with fabric, but then the landscapers come in or someone else comes in and or even the site owner, the project owner, it's just time for that silt fence to come down in their mind. And they're ready for that to look done. And so they'll remove all those measures and then mud will flow in and then the basin doesn't function and they asking questions and it may just because of their inexperience, they're just wondering why their basin's not functioning. But you've taken the time to document things. You've taken the time to protect the basin and get signed off on. And so that's critical. And you want to cover whose responsibility is it to maintain the basin during construction or after construction. And again, back to that owner step, does that owner understand that there are maintenance implications with these things, that they need to be remulched every year? And especially talk about that real quick when you're talking about remulching, that is the mulch serves as a pre-filter. It catches any sediment that gets in that pond. And so if you get a little sediment in the pond, remulching is not topping it off like you would a landscape bed. Remulching is raking that mulch out and thereby removing any sediment that was in that mulch and putting fresh mulch back down. And so that's just something that maybe not your responsibility, but probably pretty good to mention to the people that are taking ownership of that basin. And then we'll do a real quick common pitfalls recap. So we covered compaction. We drilled it. We hammered it down. We covered contamination during construction. See it happen all the time, both after the media has gotten installed and on top of the stone layer. That's no fun. Poor quality materials. There may be a guy out there that's selling cheap media out of the back of a van, but he might not be who you want to get it from. You want to work with people that have tested their media and can stand behind it. Contamination after construction. This is probably the most common. Here it is in this picture. You can see this was a basin that was installed. It's got the plants in it. It was done, but they didn't watch that silt fence and they let a blowout occur. And then, they were off busy doing other things and just, that was a checked off item on the list and they let that get way out of hand. And so that was a complete, had to be ripped out and reinstalled, including the plants. And then the landscaper often doesn't want to warranty the plants after they've been ripped out and reinstalled. So oftentimes they get you on having to install all brand new plants again. So just something to really hammer in there. Fabric over the pond after install. That is just a few $100s. And man, have I seen it save the day so many times. Improper documentation and releases. That's you definitely want to make sure you're getting all that signed off on. And then one thing that people don't realize is not just the project manager or the superintendent, but everybody on the site has got a cell phone in their pocket and they can take steps, take pictures along the way to document the steps that they've taken to reduce risk, to protect the basin, to show proper work. And so it's just so cheap. And a lot of times these things have these issues like what you're seeing here on this picture, they happen a month later, and so being able to go back and show some pictures is a great way to cover yourself. So I think that brings us to the end of our presentation, and we hope that the information today provided will help facilitate more successful installations and long-lasting bioretention systems. Bioretention is not scary. They are not failure prone as long as you respect these few things. Should you have any questions, please do not hesitate to reach out to me directly at the contact information provided here. Myself, as well as Luck Ecosystems, we want to ensure and facilitate your success in these things, and we're here to help you. So thank you so much. Have a great day, and we're going to hang around here if anybody's got any questions. And again, thanks so much.
John, thank you. That was awesome. So such valuable information. It's really important for bioretention success. I think everything that you covered. My favorite slide was the pond protection pictures that you showed side by side, and how that practice really saved that facility from having to replace the media. I think that tells a really good story right there. And then the second to last slide that you had showed if that basin had installed that fabric on top, then it would have prevented having to replace that media. So super awesome tried and true practice.
Yeah,
that we've seen work time and time again.
And and I thought about it when I was sharing about it, and I said the thing about don't reuse fabric. It probably didn't make sense there, but it seems like this fabric that's on the left does not need to be reused. It's so muddy it probably doesn't need to be reused and I hate that. I hate the idea of wasting the material, but it's just been contaminated. So that's the point I was trying to make earlier about using clean fabric, and really just needs to be brand new fabric.
Yeah, some other things that we've seen, I've seen from sort of, since I understand the engineering side of bioretention construction, is another critical point just to drive home a little bit is the contributing drainage area. It's definitely not something that a lot of contractors are noticing when they're out there. I'm sure they don't even have open that plan of the documents that shows the drainage areas are, but we have seen where drainage from a road, which is not intended to go into a basin, is now directed into it. And the problem with that is that like the surface area of these basins and how big they're designed to be is really relative to the drainage area, because you can get these systems overloaded with too much sediment if the drainage areas are too big. So that's like just a big one to keep an eye out for, that I've seen missing from, just that only a site contractor might be the one to identify that discrepancy exists. So it's really good to keep an eye out for that. We've seen silt fence just blatantly being missing from the plans. I don't think it's worth anybody's interest to just, hey, well, it wasn't there, so we're not going to put the silt fence in. We're not going to protect it from sediment running in during construction. It's an absolute must and critical component, and it needs to be brought up with the engineer as soon as that condition is seen. We have a question that was posted in the chat.
Yeah, so the stone sizes that are used, I think through time there was some experimentation going on, but it has for the most part settled into 57s in the drainage layer, and either pea gravel or number 8s in the choker layer. But and I'm not an engineer, but those choices are made based on engineered calculations, and it's all about void space and water volume and that contributing drainage area. So they're thinking about this site is an acre or 5 acres, and it's got this much impervious surface and this much soil surface, and that then equals in certain storms like 10-year storms and big ones, this equals this much potential. What kind of ask are we asking of this pond? What kind of water volume are we asking it to handle? And so that's what determines the size of the basin, the depth of the basin, and all of those things like the stone that's being selected, down below in the drainage area.
Yeah, it has to do with bridging as well. So keeping the soil media in place, but letting the water pass through. So it's incrementally increases in size from this filter media to the number 8s or the pea gravel to the 57s. Pretty common design for sandy filter materials that are used, for example, in golf courses or something like that as well, to bridge everything and keep it in place. There was a second part of that question too. And I see that your video is on. Did you want to ask any more about your question or comment, turn your mic off or contribute to the question at all? Just wanted to give you that opportunity if so.
I'm retentional product material, obviously some topsoil in there. And my second concern is being an aggregate producer as well, and being on the technical side and do a lot of stuff outside in the field, is that you'd be at the mercy. There's a lot of moving parts involved in this process, and you're going to be at the mercy of the contractor that installs all this. And with that bio product, what certification process do you go through that gets you off the hook if it doesn't perform? I know that was a
Yeah, well, I'm the product manager, so I can kind of speak to about what goes into it. And usually it's a mix of, so in the DEQ, the Department of Environmental Quality, actually has specifications that are written for the filter media to meet their criteria. So they try to account for proper functioning. So one big piece of it is the texture. So it's the percent sand that is in the media, and it has to be between 80 and 90% as tested by a soil texture test. That doesn't mean 80 to 90% concrete sand is in there, because topsoil has a certain percentage of sand in it. So, you take a topsoil and you amend it with sand to meet that soil texture in a lab that's tested. Okay. And then there's also an organic matter component that is compost, and it's very limited in what kind of compost you can use, because different feedstocks will have a negative impact on water quality. So that's also built into the spec. There's a criteria for phosphorus, and you'll find most compost that you put in there will have too high of a phosphorus, and that's what they're trying to remove from stormwater runoff. But if the soil media has too high of that to start, it will leach into the runoff. So the specs do a really good job of trying to account for what is going to influence proper performance of it. What's maybe a little not robust is infiltration testing. This is probably the weakest point of the specification and the most important, but it's really hard to equate laboratory infiltration testing to how something is going to do in the field, because of exactly what you said. You're at the mercy of all these other factors contributing to how it's going to perform in the field and over time.
That being, in other words, permeability.
Permeability, exactly. Infiltration permeability is, and so the spec doesn't account for an infiltration test spec, but we've developed as a soil provider our own criteria around when we would allow our media to be sold or not. It has to follow a certain ASTM test, a certain compaction. And we feel like that's really important, because you could test soil with 5 different tests and different compactions and get extremely different results across the board. So we try to mimic with laboratory testing what we think the field conditions are going to be.
Thank you.
Any other questions from the group? Well, thank you, John, and thank you, Kateri. That was an extremely informational presentation, and we look forward to sharing the recording with you. We'll give one more call for questions if anyone has one before we sign off.
Just real quick, just want to say thanks for everybody for attending. Really appreciate y'all taking the time to come spend some time with us and learn a little bit about bioretention. And we really look forward to working with you on your bioretention projects. Also, big thanks to the HCCA for inviting us. Thank you so much for supporting Luckstone and Luck Ecosystems over the years. We just have really enjoyed our partnership with you guys, and just look forward to doing more like this in the future. We're happy to sign up for more of these in the future if we want to take another round through other topics or another one through biofilter.
Thank you, John. Yes, we treasure our partnership with Luckstone and Luck Ecosystems as well. So thank you very much for putting this on today.
Yep.
Thank you to all the attendees. And if there's no further questions, then we will thank you all for being here and have a great day.
Bye, everyone. Thanks again.
Thanks, everybody.